I'm sure a lot of people will be disappointed.
Hello everybody, this is Black Coffee with Ice. It's your host Justin Penner here, and today we're doing something a little bit different. But before we dive into that, I just want to give a little recap on what's going on lately in the Black Coffee with Ice realm. Okay, so first off, if you haven't already, go check out mine and Colin Jackson's podcast. We get reunited after almost 10 years, and I know it's a little daunting as it's an hour and a half long, and I'm not asking you to watch all of it, but if you have 10 minutes to spare, the first 10 minutes, I guarantee you'll laugh, and if you don't laugh, you can unsubscribe, and I won't be offended. Another thing. Huge news. Next week, a good old friend of mine named Donovan Ross, he grew up here in Winnipeg, but when he was an adult, I guess fresh 18 or 20, I actually don't really know when, but he moved to Toronto, and in the cocaine he was doing, there was some fentanyl in there. He ended up overdosing, flatlined, pronounced dead, got revived, heart was working again, and now he's going to come here. He's going to come all the way to Winnipeg just to talk to me on Black Coffee with Ice about his new perspective, and it's going to be really crazy. A lot of people that we know do cocaine. Yes, it's an obvious thing, but the reality behind it is no one knows where it's coming from. No one knows what's in it, and tune in because the next one's going to be very big. But for this one here, this is basically a science segment. So for those of you who don't know, I have a little piece of paper, a little Bachelor of Science in Biochemistry. But not only did I study that, it actually is a passion of mine. Just mixing up physiology, the easy chemistry from the body, how that applies to longevity, health, fitness. I have a passion for teaching it too, because I feel that if no one's in science, they're not going to learn this stuff. And so today I'm going to be talking about this thing that I use called Coenzyme Q10. And why would you want to listen to this podcast about Coenzyme Q10 with me just talking by myself? Because I will teach you about how the body creates energy for itself and how basically oxidizing things increase inflammation, whatever. I'll explain all this more in detail. But Coenzyme Q10. Why is it called Q10? Well, 10 because there is 10 isoprene units. That means nothing to you. But when you take this, theoretically, and from my own personal experience, it does increase your energy levels, decreases inflammation, and the energy levels are associated with the increased mitochondrial function. So there's a plethora of potentially good side effects from taking this drug, taking this supplement. But all those good things, they boil down basically to inflammation and mitochondrial function. So in order for us to explain the mitochondrial function, I have to explain what the mitochondria does. Mitochondria equals powerhouse. The end. Ha! Just kidding. Obviously not. Okay, so before we dive into this is going to be a little lesson. This is going to teach you how the body works, okay? And some basic chemistry along the way. So these are type of mnemonics that I use, and I will continue using probably till I die. So just remember GER and LEO. So GER, gaining electrons equals reducing, okay? And then LEO, loss of electrons equals oxidation. So we can treat a gain or loss of electrons just as an addition or a subtraction of an hydrogen molecule. So this NAD, to become this, what is it doing? It's gaining an electron. It's reducing. So this is the reduced. That's the oxidized because it doesn't have the electron. And so this is going to come into play with respect to different energy carrier molecules. So in order to explain the mitochondrial function, we have to explain the cell. All living things are made of cells. It's the basic unit of life. It doesn't get much smaller than that, like with respect to living things. So basically, this is the cell. There's a bunch of different organelles. Organelles are essentially just organs of the cell. So here's the nucleus. We have the nucleus here. We have DNA inside. This is the endoplasmic reticulum. You got some ribosomes, and I'll explain in another video. But proteins are made from the DNA. It sends out the message, and the ribosomes constructed, and yeah, there's all these different things here. Lysosome, so that's like the stomach of the cell. But today we're gonna focus on the mitochondria. So there's mitochondria here, mitochondria there. We're gonna go a little bit more into just the powerhouse. So here is the mitochondria. All right. So just to explain some compartments of it. So this is a cross section. So it would look like this, whatever, but this is just like if it was cut in half. So this is the outer membrane. This is the matrix. This is the inner membrane. And then right in between is the inner membrane. Oh, sorry, intermembrane space. Okay. So that's the mitochondria. How we make energy comes from, so first off, we basically eat food, right? Food gets broken down into energy. So there's some cycles that happen, and these cycles are just a specific series of chemical reactions. So this is the cytoplasm. So glycolysis happens in the cytoplasm, and then the Krebs cycle happens in the mito, and then I'll explain the electron transport chain in the mito right away. Okay, so this is glycolysis. Basically, starts at glucose, gets broken down at each step. There's a different enzyme at each step, and we're going to break this down slowly. We don't have to get into the specifics of this, but okay, so from glycolysis, you start with the glucose. You end off with 2 pyruvates. So each pyruvate will go through the pyruvate dehydrogenase complex. Then it'll split out acetyl-CoA. Acetyl-CoA is just a molecule that can either go towards fatty acid synthesis or it can go in the Krebs cycle. So we'll explain there's all these different molecules, and there's a slight modification at each step. So for each pyruvate molecule, you will have 3 NADHs, 1 FADH2, and you'll have a GTP, which is the equivalent of an ATP, which is the energy molecule. NADHs are actually worth 2.5 ATPs, while FADH2s are worth 1.5, and we'll explain that in just a minute here. All right, so this is the electron transport chain. This is where the magic happens, baby. This is basically the inner membrane. This is where this is happening. This is where that fun stuff's happening. So this is called the electron transfer chain. And what we have to memorize is that where there's a concentration gradient, that means there's energy. All right. So this is the intermembrane space. This is the inner membrane right here. So imagine the outer membranes are out here, and the matrix is just in the middle. So the reason why NADHs are worth more than FADHs too is because FADH2 bypasses complex 1. So how we get energy from the electron transport chain, I'll explain. So electrons from, so remember, Ger and Leo. So Ger, reduced. Gaining of electrons is reduced. So these are reduced electron carriers. So they give the energy, they give the electrons through complex 1. FADH2 gives through complex 2. It goes through coenzyme Q in the Q cycle, which I'll explain momentarily. From there, the energy goes into complex 3. Complex 3 passes 1 electron to cytochrome C. Cytochrome C goes back and forth, carrying 1 electron per time. But as this is all happening, so as the reaction is happening at complex 1, 4 hydrogen ions shoot across into the intermembrane space. Okay, complex 3, 4 hydrogens shoot out into the intermembrane space. Cytochrome 3 brings the electrons, and what we have here is a reaction coming up. Oxygen here is the final electron acceptor. It gets reduced to H2O, water, and only 2 hydrogens are pumped through complex 4. So what we said before, concentration gradient equals energy. Okay, so there's a concentration gradient here. There's this enzyme called ATP synthase. The pool of hydrogen ions in this intermembrane space flow down the ATP synthase. There's a mechanism called chemiosmosis. I'm not going to explain it, but essentially from ADP, it makes ATP. All right, so the reason why FADH2 is worth less than NADH is because this bypasses complex 1, so there's 4 less hydrogen ions pumped per FADH2 compared to NADH. All right, so now we're going to explain the Q cycle, because that is where coenzyme Q actually really chills. All right, so there's this thing called the Q cycle. Imagine this is complex 3, okay? Each time this is complex 3. All right, so a reduced coenzyme Q right there, okay? Oh, no. Oh, whatever. Okay, so say a reduced coenzyme Q right there. Basically, we'll go into complex 3. It'll give 1 electron to a oxidized coenzyme Q, and then it'll give an electron to cytochrome C. So as we remember, this is right here. Essentially, the Q cycle is happening right here. It basically gives an electron to cytochrome C. This is the next step. Okay, so since this reduced coenzyme Q gave its electrons to cytochrome C and the oxidized coenzyme Q here, the now oxidized, previously reduced coenzyme Q goes out back into the coenzyme Q pool, leaving the original oxidized coenzyme Q with an electron, and the cytochrome C is free to take it to complex 4. All right, so now, the original coenzyme Q that was reduced, that got oxidized, that went out into the pool and picked up some more electrons, comes back into complex 3. So now the coenzyme Q gives the originally oxidized coenzyme Q with an extra electron another electron, therefore giving it 2 electrons, making it reduced. Now the coenzyme Q with the 2 electrons gets H pluses from the matrix. While this is happening, the reduced coenzyme Q that gave its electron to the originally oxidized coenzyme Q with an electron gives it another electron. It also gives another electron to cytochrome C, pumps out another 2 hydrogens. Now oxidized and now fully reduced, coenzyme Q are able to go either back into the Q pool and continue the processes again. All right. So that's basically the mechanism behind coenzyme Q. It's very important in the mitochondria, and as you can and from a lot of recent data, it has been proven to increase mitochondrial function. So you have more of that protein, you get basically more ATP per amount of oxygen reduced. Okay? Oh yeah, it's right here. Increase the number of coenzyme Q, increase the ATP per oxygen reduced. All right, so let's talk about free radicals. So that was basically the mitochondrial function, just how the body works. That's why this is so fascinating. All right, so now I want to talk about the antioxidant part of coenzyme Q. So free radicals. What are free radicals?
First off, we must remember that electrons go in pairs of 2.
Free radicals are basically things that are missing one electron or have too many electrons. And it can take electrons because it wants to have two. So if it's missing one or has an extra one, it can go around and oxidize things. So what's oxidation? Loss of electrons, baby. So it's going around, it's stealing electrons from things. And what an antioxidant does, it has an extra electron. So it can fill out the shell here, or it can take one of the extra electrons from there. Okay? Reactive oxygen species are essentially free radicals. They go around, they steal electrons, they oxidize things, okay? So when there's a lot of free radicals, a lot of ROSs, inside the mito, the DNA is screwed up because the mitochondria has its own DNA compared to the rest of the cell. That's from endosymbiosis theory. I guess the genesis of a mitochondria came from a cell engulfing another cell, and that's the mitochondria essentially. So that's why it has its own circular DNA. Anyways, so a lot of reactions in the body that need to happen end up causing free radicals to be formed. Antioxidants are the solution to this. And there are 4 antioxidants that are lipid soluble. So lipid soluble means that it's fat loving, it's water hating, it's hydrophobic. There's hydrophilic, which is water loving. It's the opposite of that. So I guess just to break it down, hydrophobic, there's no polar bond. So so water, for example, is HHO, but there's a higher density of negative charges there and positive there. So this is a polar bond, which is hydrophilic. And then if you just have a bunch of carbons like that with no polarity, that is nonpolar, which is hydrophobic. So lipid soluble. And this is water soluble. Okay, anyways. So there's coenzyme Q basically just reduces free radicals. It defends proteins from oxidation. Oxidative stress may damage DNA. Now the Denver paper. From this one university website, I found that coenzyme Q has actually helped people with mitochondrial encephalopathy, which basically is brain dysfunction, lactic acid buildup. It's been proven to have a positive effect on people that have congestive heart failure, and actually has favorable effects when they are on those drugs for that certain condition. It has been proven to help people with angina. Is it angina? It's been proven to help people with chest pain, and that's the main reason why I wanted to take it, because my grandpa died of an MI, so acute myocardial infarction. I don't know, but it's been shown to have protective effects from that. And coenzyme Q has been known to lower blood pressure, so it works synergistically with other blood pressure lowering meds. That's the main reason why I actually started taking this, is because when the doctors thought that I had hypertrophic cardiomyopathy, for one thing, it would protect my heart. For another thing, it would protect my heart by getting rid of the radicals, being an antioxidant. Okay, this is it's highest concentrated in the heart itself. So another thing was how it lowers blood pressure. So when the blood pressure is high, your heart has to work harder to pump more blood. It's thicker, it's more to pump. So when you lower the blood pressure, the heart doesn't have to work as hard. So I was thinking, maybe I should just take this, lower the blood pressure a little bit. Maybe my left ventricle will shrink, whatever. Turned out to be a false positive, as you already know, but just wanted to let you guys know. And it's actually been shown on people that have HIV that it's increased their immune system activity. So it's immunostimulatory activity. And basically, when you have coenzyme Q deficiency, you can have seizures, you can have weakness, fatigue, and just like due to the antioxidant effects, it has this tremendous potential. Yeah. And just make sure before you take anything, you have to see your doctor, because ultimately, I can tell you what I do and the research I've done, but I cannot necessarily tell you that it's going to be safe for you, because it might not be. So the main thing you should do is go see your doctor. I appreciate this science segment. I hope that you learned a little something. And please just let me know if you guys like this format. If you don't like it, too bad. No, I'm just kidding. But no, seriously, just let me know. Have a great day, everybody. Make sure to tune in next week. We are on with Donovan Ross, the fentanyl overdosed man, who's not overdosed no more. He's good. All right. Yeah. Yeah.
I'm sure a lot of people will be disappointed.